Origins of the First Americans. Written and narrated by D.W. Graffin. Recoverable DNA. Researchers argue that they were descendants of the first wave of settlers who crossed the Bering Land Bridge perhaps 20,000 years ago. These bands eventually followed channels from north to south that cleared of ice and crossed all of North America, Central America, and eventually South America. But it all began around 47,000 years ago in Siberia and Central Asia. Was the era of land bridges, and it was the era for great migrations of modern humans. As more land became accessible to these ancestral nomads, they moved for the first time from Asia into North America, mostly in small, mobile bands of 20 to 60 related people. All of these cultures made stone blades of various styles that changed by region and era. Some were used for scraping hides, or perhaps bodily use, such as shaving. Some were fixed to antler or bone foreshafts and used to hunt an abundance of game in the forests and rivers, although many of their winters may have been times of deep privation. A brief list of the animals paleobiologists have identified in this region include American mastodon, ancient versions of camels and cervidae such as elk, moose, and deer, and pantherinae like cougar and cheetah, and the giant American lion, who could reach 400 kilograms. Also, they hunted early versions of the muskox and bison, horse, and giant beaver. The nomads followed these and other species across what is now known as the Mammoth Steppe for the number of butchered mammoth bones that have been found in northern Siberia from this period. We know Native Americans emerged from Siberian and East Asian peoples, but so many of the details remain unknown, and the subject remains one of the most contentious in all of anthropology. How and when did the Paleo-Indians first arrive? Do all modern Native Americans share common ancestry, or did different ethnic groups come in waves? How and when did these migrating populations radiate southward over both North and South America? The DNA lend more evidence to what is becoming more of a standard theory on the origins of the first Americans. Modern humans emerged from Africa over 60,000 years ago, when haplogroups that persist in populations today first emerged. The paternal lineages Q, R1, and CP39 arose in Siberia and Central Asia and made their way east toward the far borders of the continent. Nearly all of the peoples of pre-contact North and South America descend from these same few haplogroups. Genetic studies have shown that up to 95% of native North, Central, and South Americans share a lineage that first separated from other East Asian populations while still in southern Siberia or Lake Baikal, approximately 36,000 years ago, give or take 1,500 years. The mitochondrial, or maternal DNA of this same 95% of modern Amerindians contains haplogroups A, B, C, D, or X. It also indicates that they all share a single ancestor who arose in Central Asia, although X is the only one to have no modern presence there. This curious absence has led to various models, including the Solutrean hypothesis, that attempt to explain how haplogroup X migrated across Asia, Europe, and the Americas. This model links the initial peopling of the Americas with European populations instead. But so far, apart from a number of curious, atypical bones without DNA that have been found in northern Norway, and a similarity between prehistoric European stone tools and those found in Clovis, New Mexico, the mitochondrial DNA evidence that we do have hasn't convinced the academic community of any prehistoric migration across the Atlantic, at least not from more than 20,000 years ago, as its supporters claim. But other researchers have made connections between the first Americans and populations that ended up in Western Asia and Europe. Beginning in the 1920s, the Malta site near the shores of Lake Baikal have been extensively studied, before Eske Willerslev and his team were able to sample mitochondrial and Y chromosome DNA retrieved from within an upper arm bone. But his lineages seemed all wrong. At first they didn't believe the results, and assumed that the U and R haplogroups they found had been the result of excessive handling by European researchers. But then the team began to see U and R haplogroups in other related remains, and they began to construct a hypothesis. The real surprise is that Malta boy has no relation to current populations of East Asians. He is more related to the peoples who eventually migrated westward and laid the foundations for the first European lineages. These founding populations still start in Central Asia, in a time before such distinctions mattered. The great open expanses of Alaska were connected to Siberia from around 30,000 to 11,000 years ago. Conditions appear to have been the most likely for immigration out of Siberia from west to east about 20,000 years ago, when the land was not too barren and glaciers of the region receded. So this has become an era that many anthropologists and archaeologists have focused on as when the very first humans walked into the Americas. Researchers have identified long eras where the glaciers blocked movement and trapped entire populations of humans and animals, sometimes for thousands of years. These kind of isolating events and the mutations they cause, reinforced over generations, are what originally divided modern humans into distinct haplogroups in Africa. In 2018, the DNA found were studied in depth by an international team led by Danish evolutionary geneticist Eske Willerslev in a paper published by Nature. Terminal Pleistocene Alaskan genome reveals first founding population of Native Americans. The children were found to be from an earlier branch of the lineage that all Native Americans share. Other ancient Arctic and subarctic burial samples like the Nenana and Denali were found to be only distantly related. They were a newly discovered people, a long-lost population that researchers call the Beringians. Trapped by glaciers on every side, these Pleistocene nomads likely inhabited a 1,000-kilometer-wide swath of northeastern Siberia, the Kamchatka Peninsula, and Alaska, called Beringia, for at least 5 millennia. Mitochondrial DNA of multiple ancient samples and ABO blood groups distributions support the theory that the population who lived in Beringia during that time was trapped on a land bridge that today is mostly under the frigid waters of the Bering Sea. The last glacial maximum had exposed the land, but also created impenetrable walls of ice to the east in Alaska and back the way they had come in Siberia. A number of mutations have been detected in mitogenome samples that can usually only be amplified by a population that had no outside genetic influences for 5 millennia. This effect has been found in numerous other studies on Beringian dig sites and in paleolinguistic research as well. The theory is now referred to as the Beringian standstill population. That doesn't mean that they are the descendants most closely related to the Beringians, however. Later migrations swept across Alaska and Canada that mostly supplanted the original population. The difficulty researchers face when trying to build models of the migrations of the first Americans is that there are so many complicating factors over such a long period of time, and new discoveries have recently come so fast and furious, in academic terms, that no one can yet claim they have constructed a fully comprehensive theory. A lot of that is due to the fluidity of the climate over thousands of years, the presence or absence of ice, and the great megafauna migrations that responded to each change. These first Paleo-Indians followed the herds into the New World on foot, and so far our earliest evidence of them is in Clovis, New Mexico, approximately 11,600 years ago. Or perhaps they migrated south, along the coast by boat. The Monteverde discoveries in Chile may be somewhere between 14,600 and 18,500 years old. They are the example most frequently used by those who hold that the peopling of the Americas was first done not on land, but along the western coast, following the currents of the Pacific. But their hypothesis has yet to gain consensus in archaeological circles, mainly because the dating methods used in Monteverde remain hotly disputed, and most of the sites any migratory boat people would have used followed a coast that is now under an average of 100 meters of water. Yet archaeogenetics and paleogenomics have been able to add many insights into the history of the first Americans. Autosomal DNA samples of Native Americans show that pre-European contact genetic diversity decreases the further one lives from the Bering Strait. Samples of native, modern, and ancestral South American mitochondrial DNA suggests that those who followed the coast might indeed have reached southern Chile by 18,500 years ago. Here is what linguists have to say about these peoples. In a 2014 PLOS ONE paper, linguistic phylogenies support back migration from Beringia to Asia. Researchers compare how ancient languages borrowed terms and evolved new ones to provide insights into ancient migrations. Although they acknowledge most migrations preceded the generally accepted 8 to 10,000 year limit of the traditional comparative method of historical linguistics. They continue. DNA evidence supports at least 3 migrations, with the earliest 15 to 40,000 years before present, referred to generically as the Paleo-Indian, and associated with the greatest distribution of language and cultural groups across North, Meso, and South America. The second, 12 to 14,000 years before present, is the Na-Dene, distributed in North America from Alaska to the Pacific Northwest and from Canada to the U.S. Southwest. And the third, circa 9,000 years before present, is Eskimo-Aleut, with circumpolar distribution. Linguists have classified Eskimo-Aleut and Na-Dene as separate language stocks, and the rest of the languages of the Americas as belonging to numerous stocks, but have otherwise been mostly silent on questions that connect Asian and the American populations because, with the exception of Eskimo-Aleut, the dates of these earlier connections lie beyond the traditionally accepted limit for comparative reconstruction. For the record, the term Eskimo is problematic on a number of levels. To quote from the Wikipedia page on the subject, many Inuit, Yupik, Aleut, and other individuals consider the term Eskimo, which is of a disputed etymology, to be unacceptable and even pejorative. Eskimo continues to be used within an historical, linguistic, archaeological, and cultural context. It is within that formal linguistic context that it is used here. The Yenisei River is a region in Siberia whose language families spread to northern China and Central Asia. One hypothesis for their success is that they were able to survive along the swampy verge of the Yenisei River because mosquitoes prevented the reindeer from thriving. For the Nadene, an ethnic and linguistic family that contains everyone from the Ayak and Tlingit of Alaska to the Athabascan speakers of Canada and California to the Navajo in the American Southwest, their descendants may owe their migratory success and survival into modern times to the humble mosquito. Linguists have studied a connection from 15,000 years ago between haplogroup Q and Yeniseian languages that appears to be the bridge between Central Asia and the New World. Their conclusion: we use Bayesian model comparisons based on Bayes factors to test the fit between the linguistic phylogenies modeling the two dispersal hypotheses. Our results support an argument that, if the Dene-Yeniseian connection is true, it more likely reflects radiation out of Beringia with both eastward migrations into North America and westward migration into Asia, rather than a unidirectional migration from Asia to North America. This supports the growing number of studies who conclude that once the Beringian standstill population was released from their glacial prison, they radiated back into Siberia as well as moved forward into the unpeopled Americas. The population that had been trapped so long now migrated south and east through Canada. Their genetics tell us that they met no one new along the way. They only carried haplogroups that arose in Central and East Asia on the far side of the Bering Strait, and they spent the next 1,000 to 2,000 years migrating south over land all the way to Tierra del Fuego. Again, they may have traveled along a coast that has long been submerged. The maternal haplogroup X2A has been traced through this interior corridor, and mitochondrial DNA of D4H3A indicates that people likely followed the Pacific coast to the south between 15,000 to 17,000 years ago. There is also the Kelp Highway hypothesis, advanced by coastal anthropologists, which has studied the possibility that the rich kelp forests of the Pacific coast from Japan to Beringia down to California could have easily sustained a migratory population during this time. If coastal populations with the same genetic background did come down the coast first, the walking migrants might have met their distant cousins in the river deltas and watersheds of the North American and South American West Coast. But so far, mitochondrial and autosomal DNA neither supports nor rejects that supposition. Now, for the 5% of the Native American population that this research doesn't account for, the Inuit-speaking populations of southern Alaska and British Columbia represent a haplogroup that arrived as a later, second East Asian wave. Other later waves arrived from Greenland and East Asia. A controversial finding that North American and Andean samples share a mutation with Japanese Jomon remains unresolved, but the disputed arrival of populations from Polynesia into the Amazon and from Africa to the Caribbean seem to have no serious adherence to their theories. But the disputes are far from over. In the process of writing this article, a new discovery from southern China reveals even more clues. 2 models fit the data that they discovered. This is an example of a remnant population left behind by migrants who found success elsewhere. Or it might be that this is an example of a coastal population who had already been to the Americas and returned all the way back to southern China. If true, this might indicate a surprisingly high level of travel along the North Pacific coasts over thousands of years. So much of this story remains untold. Many native oral traditions in both North and South America speak of their first arrival on their lands to find that someone was already there. Who were these old ones their people displaced? How many waves swept the old peoples aside for the Americas to be colonized yet again? We may never fully know.